Yeah. What time you got to movie?
I don't know.
Not too late.
I don't know. Well, we have to wait for Cameron. He gets off at 7.
Okay.
So we got time. Hi, guys.
Hi.
Oh, Amy here? We got her?
Is she here?
I don't know. I just see Amy on the bottom left. Or maybe she's invited. Maybe that's what it means.
Yeah, maybe.
Does anybody know if she got her internet up?
I don't know.
So I just finished the homework for the weekend.
The lesson 11 homework?
Yeah.
Did you do really bad on that?
The lesson 11 homework?
Yeah.
I got an 80 on it.
I got a 70 on it.
On the quiz?
Yeah, on like the individual homework assignment.
Oh, I didn't do that one yet.
Oh, I don't know what I missed. I can't see it yet, so.
I think I know what I missed. I think I missed 3. Just because I know I put the wrong numbers down. Like I looked at my work and I switched them, so I know I did it wrong. Biostatistics. Individual preparation. Well, how long are we gonna wait? No, I need to go back to my room. My room is loud.
Let's see if it makes it.
Hey, shut your mouth. Okay. So I took a nutrition test today. Pretty much bombed it. It's a great day. Wow, this one's huge. Ugh. Oh, no camera or microphone right now, sorry. Got it, finally see it. That's what Amy said.
Oh, so she can hear us, but we can't see or hear her.
Yeah. So she left, though. She left the group chat.
Oh. So does that mean we should start then?
Well, I mean, I bet she just, like, her internet freaked out for a second, and she's... Well, we could start. It's not like... I guarantee she already has all the homework done. She always does. So we can at least start on just the individual... Talk about it. Second half.
Okay.
So...
Alright. So we did... We only did part 1 on this, right?
I thought it said do both of them.
Oh, yeah. It did. Yeah, I did it.
Yeah, I did mine. Let's talk about it. Cancel. Yeah.
There it is.
I'm so mad about that nutrition test. I've never gotten a 69 on the test before. Frustrating.
Okay.
Alright, we ready?
Ready. Should we just pull up the answer key and go over our answers for the part 1 and part 2?
Yep.
Done and done.
Perfect. I can pull up the answer key really quick. Okay. Okay, I got it. So, number 1 on part 1, listed at least three characteristics. It says symmetrical, mean of 0, exact shape depends on the degrees of freedom, bell-shaped, more area in the tails than the standard normal distribution. Then number 2, degrees of freedom equals n minus 1. And then number 3, you have the x minus the t value times s over the square root of n, and then x plus the t value times s over the square root of n. And then number 4, it says what are at least 2 differences. It could be sigma is not known. We compute a t-score from the student t distribution rather than a z-score from the normal distribution. And we must now consider degrees of freedom for the t distribution, whereas normal distribution you don't. And then number 5, the formula is t equals x minus the mean all over s over the square root of n. And 6 says, what assumptions need to be met? A simple random sample was drawn from the population and x is normally distributed. And then number 7, it says sample mean equals 46.73 and sample standard deviation is 8.83. So now we're on part 2. And number 1, what are the requirements? It says it is a random sample from a population and the x's are normally distributed. And then number 2, the interval is 41.8 to 51.6. 3 is 39.9 to 53.5. Number 4, A, is 41.8 to 51.6. B is 39.9 to 53.5. 5. The margin of error for the confidence interval is smaller for a 95% confidence interval. The margin of error for the confidence interval is smaller for a 95% confidence level than a 99% confidence level. Number 6, A, the null hypothesis is that the mean is equal to 47, and the alternative hypothesis is that the mean is not equal to 47. And B, you use your t equation and plug in those numbers and get negative 0.118. C, the degrees of freedom equals 14. And then we should have the sketch of the t distribution that represents, and then the shaded where the p-value is. So since it says not equal to, it should be like both tails shaded in. E, use your software to compute the p-value. The p-value is 0.9077. F, we fail to reject the null hypothesis. And G, we have insufficient evidence to conclude that the mean age of this realtor's customers who are buying second homes is different than the natural average. That's just the national average. And that's it.
All right, I got the majority of them right.
Sweet.
Why's my door?
Is Amy here?
Yeah, Amy's here.
Sweet. Alright. We just do the...
Yep. She muted herself. That's pretty funny.
Alright, so... Are we all going to start?
Yep.
Okay, let's do it. One, two. Alright, so number 3. In previous lessons, we have assumed the population standard deviation, sigma, was known. In this lesson, we are making a different assumption about sigma. What has changed?
We
And
said unknown.
yeah.
Sorry, somebody just came to my apartment and I have no idea who they were. He literally just walked in, looked in my fridge, and then walked out. I was like, well, welcome. Okay, so we assume that the hypothesis is unknown, right?
Right. Standard deviation is unknown.
Yeah.
Alright, so number 4, the null hypothesis is that the mean is equal to 8, and the alternative hypothesis is that the mean is greater than 8, and the population standard deviation is not known. Becca collects a sample of 9 and computes that the mean is 11, and the standard deviation for the sample is 6. Uses information for questions 4 through 5. So is sigma known? No.
No.
What is the value of t? Do our equation.
Gotta bust out our equation.
Let's see.
Gosh, I got a headache. Did you guys read what Amy put?
I can't see it.
I can't either.
She said, I gave up. My computer won't work. I can't hear anything. Could someone could someone message me when we're gonna meet next and I'm gonna work on it.
Okay.
Pretty funny. I should have been like, well, we could hear you, so
Alright. I'll message you when we're done when we set up a time.
yeah.
Okay, so I got 1.5.
That's what I got.
Yep.
Perfect. 1 decimal. Perfect. Alright, so use the following values which were pulled from the data file body temp and copy and paste them into the software you are assigned to use. Okay. Using the null hypothesis of mean equals 98.6 and the alternative hypothesis of the mean is less than 98.6 and a level of significance of 0.05. You have to copy and paste that all.
Mm-hmm.
Okay.
I hate copy and paste and all this stuff.
Me too. I think you just do it all at once.
Yeah.
I didn't know that until just now. What is the mean?
So do we just use 95% for the confidence interval?
Yeah, that would be the confidence interval.
We're
And
using 95?
Yeah, that's what I'm wondering, because it didn't give us that. It just said use the level of significance at 0.05. So is 95 just like standard?
Yeah. Well, 95, it's like 0.05 is, like, it has to be a level of significance of like less than 5% to reject it. So the
Right.
0.05 correlates to the 95%. And then if it was 99%, it would be 0.01.
Okay, I I thought maybe I couldn't remember how they were related. So, okay.
Yeah, I'm lost. I have no idea what you guys are talking about. We'll just put it in, and then
So for 6, I don't think you need that, right? You just find the mean of the data?
yeah, pretty
Okay.
much.
So I just got 98.220.
Which is the mean.
Yeah.
I just did them all at the same time, and then, I don't know.
Oh, okay.
I don't know.
So everybody did get 98.220, right?
Yeah,
Right.
for the
Okay.
So that's number 6.
yeah. And then for the rest of them, just to do them all at once, you go to compare means, right? You go to analyze, compare means, and then one sample t-test.
Mm-hmm.
Okay. And then we have to put our test value in as 98.6, correct?
Yep. So that's what I asked up at the top, right? 98.6. U equals 98.6.
Okay, wait, compare means in one sample t-test?
Yeah.
Okay. And sorry, where did you put the 98.6?
I put it, so you went to analyze, compare means, one sample t-test, and then in that little tiny box there that says test value,
Oh, okay.
I just put it there.
Perfect.
So let's see. Number 7 wants to know the sample standard deviation. 0.922.
Oh.
Yeah, 0.922.
Okay. And then the t-score is negative 1.843.
I don't have that yet. Why wouldn't I have that?
It should be in your one sample t-test box, in that second box.
Did she not check it?
Oh, I got it. Negative 1.843.
Yeah.
So, again, 7. 0.922. That's what I got.
Right.
8.
Yeah.
Negative 1.843. Sorry.
Yeah.
Right.
Perfect. Just making sure I'm looking at the same thing as you guys. Perfect. The p-value. Sorry. I'm starving right now and I'm eating a bag of chips at the same time, so it's a little distracting.
It's all right.
Alright, so our alternative hypothesis is a one-tailed. We would take that and divide it by 2, that little sigma two-tailed thing. 0.081 divided by 2.
I think I just lost you.
For the p-value, are you using SPSS?
Yes.
Okay. So to find the p-value on that one, you see that box that says like sig two-tailed?
Yes. 0.081.
Yeah. So if it was a two-tailed test, you would just use that number it says.
We have to divide it in half.
Yeah, if it's a one-tailed, you just divide it in half.
Okay.
So what number are you taking and dividing?
That box that says sig two-tailed?
Yeah.
Since it's only one-tailed, we have to divide it in half because that's just SPSS only calculates as a two-tailed.
And p-value is equal to two tails.
If your hypothesis says it's not equal to, then that's a two-tailed and you would just use that number. But if it says it's like greater than or less than,
Then it's two tails.
then it's one-tailed.
Oh, okay.
And you would divide it in half.
Perfect. All right.
So you're saying that that's what the p-value is 0.0405?
Yeah. So 0.041 then for
Yeah.
rounding? Okay.
What is the correct decision based on this evidence?
It's less than the level of significance.
So we reject it?
Yeah.
Sweet. Okay. Now I'm going to delete all that so I can copy and paste the new stuff.
So we rejected the null hypothesis.
Yeah.
Perfect. Okay.
Use the following values which were pulled from the data file, baby boom. These values are the wait time in minutes between births at a hospital. Copy and paste them into your SPSS. So the hospital claims the average time between births is 40 minutes and plans its resource allocation based on this claim. You want to test their claim that the mean is 40 minutes. Copy and paste that.
So the mean is equal, so now it's already two-tailed, right?
Right. Not equal is two-tailed.
Yeah.
Okay. So we don't have to change anything, right?
Well, so 0.01, does that change the confidence interval percentage?
Yeah, that would be a 99% confidence interval. We do. Okay, so we gotta go analyze, compare means, sample t-tags. What did they say the mean was in the null?
40?
40, okay. Oh yeah, there it is right there. 40. And we have to change that to 99%. Okay. It wants to know the p-value.
So is that 0.876?
That should be 0.995.
Wonder if I didn't change it.
Let's see here. Let me copy and paste that. There's 21 things, right?
Mm-hmm.
Alright, so then we go to Analyze, Compare Means, One Sample T-Test, select our thing. So the test value should be 40, and then we go to Options and change that to 99%.
Yeah.
I did not. I must.
And then hit OK.
So there's 13 values?
There should be 21 values.
21. Let me count them again.
Maybe I didn't copy them all. Hold on.
21. Exactly 21.
My screen was too small, so I thought I had them all. Hold on. Why do I only have 20?
No, did you get 59 and 61?
I have 59.
61 should be your bottom one.
61's not. Oh, there we go.
Are you in, like when you copy and paste it, are you in the variable view or the data view? At the
Variable.
bottom?
My other screen for the quiz was is little, and so I didn't. I'm
Oh.
there. Give me 1 second, and I'll get it.
Yeah, sometimes it's easier to copy and paste if you're in the data view.
Oh, really?
Yeah. I had that same problem a few days ago.
Okay, here I am. So 0.995.
Yep.
Perfect. So then on number 12, we failed to reject the null because it's higher than 0.01.
Mm-hmm.
Sweet. Okay, so 13. You decide to try another alternative hypothesis. This time you use the mean is less than 40, and you keep the same level of significance. Did the p-value increase or decrease? So we just got to do all that. Well, we could just use the same stuff, right? And
Yeah.
divide it.
Wouldn't it just decrease because you have to divide it by 2?
Yeah, I think so. Let me see. 0.995 divided by 2. Yeah, because then it's 0.4975.
Yeah.
Is that less than or 0.01?
That's still higher than 0.01.
So we have to reject it again.
Yeah. So yeah, that's number 14. Reject. Or wait, failed. Wait, hang on.
Yeah.
So failed to reject it.
So.
Okay, so 14 is failed to reject.
Compare the width of the confidence interval in question 11 to the confidence interval for question 13. Which one is wider?
Question 13. Oh.
So 13 is.
Since the in 13. The confidence interval is the same, isn't it? Because we use the same level of significance.
Uh-huh.
What does it mean by which is wider?
Like which one has more numbers in it, I guess.
Oh, well then yeah, they're the same.
Okay. Because we didn't change any of that, we just changed the p-value.
Right.
Okay. So then we should be done.
Yep.
Perfect. I'll hit submit. 100.
Awesome.
Baller. That's always nice. Alright, when are we meeting next time? Can we go back to Mondays and Wednesdays at 1?
Yeah, I can do.
Yeah, this week I can do Monday and Wednesday at 1.
Perfect.
All right. So I will tell Amy and set it up.
Alright, thanks guys.
Okay, cool,
Yep.
thank you.
I'll
No
see
problem.
you guys.
I'll post the link too. See ya.
Alright,
Yeah.
bye.